Okay, we move on to discuss this formula in a little bit more depth. Okay, so we already know that this one for parallel plate we can use this version of this equation, right? So this is the general equation, this is the special case, and this applies only for parallel plate. So when do we use the general version? Okay, we use the general version when we come to any potential against distance graph, right? So let's say this is a question from your Cambridge exam 205 paper 1 question 20. Okay, let's say we have a question that gives you a graph of potential against displacement. Okay, and the question asks for the greatest magnitude of electric field, right? So the options are A, B, C and D, right? So if I look at this formula over here, right, this formula is especially important when we look at graphs, right? The negative sign is important in graphs as well, right? So what kind of information can I get from the graph that tells me electric field? From this formula you should clearly be able to tell that the gradient of the graph, right? Because this is the y, this is the x, so this is actually dy dx, right? Where v is the y and d is the x. Alright, so if I look at the gradient of the graph, that tells me electric field strength. Where's the highest gradient is what the question is trying to ask, because they ask for greatest magnitude of electric field. So D and B are obviously out because they are 0. If I look at C and A, which one has higher gradient? Okay, it's clear in this case that C has higher gradient than A. Alright, so C is the point which gives me the greatest magnitude of electric field. Right, so answer is C. Alright, so in this case, if A happen to be steeper, right, let's say because A is a negative gradient, C is a positive gradient, right, because I only care about the magnitude, I only care about the gradient's number, I don't care about the sign. So if A happen to be steeper, right, let's say A's gradient is steeper than C, then the correct answer to this question will be A, right? Greatest magnitude of electric field will be at A, right? But in this case, it's clearly C has a steeper gradient than A, right? We move on to discuss what this diagram is about, right? Hopefully you realize that this VD graph is actually the VD graph of your parallel plate, right? I know that electric field is a constant, so I know that the gradient is a constant, right? So the gradient has to be a straight line, but whether it's a straight line down, straight or up depends on where I start my D from. If I start my D from the top plate, which is the positive plate, and move down, right, I should realize that my potential is dropping, right? From the positive to the negative, my potential should drop, right? So I must go downwards, right? So with the hypothetical values that we used earlier, 5 volts and this is 0 volts, right, I should range from 5 volts at the start, be a straight line because constant gradient, all the way to 0 volts, right? And this distance over here is this distance, right? So I call this distance D1, okay, assuming this distance is D1. Alright.